Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is November 2018, paper 4, higher tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Welcome along to another OCR GCSE Mathematics past paper walkthrough. Today we're going to be having a look at the November 2018 series, and I'm looking at paper 4, which is the first higher tier paper. You'll remember papers 1, 2 and 3 are foundation, and 4, 5 and 6 are higher. Okay, it's a calculated paper, so let's get cracking. Question 1. Shari buys a box of 60 candles for £125. She sells the candles for £2.25 each. Calculate her percentage profit. Okay, well her profit is going to be how much money she had coming in, less how much money she's got going out. It's income less expenditure, isn't it? So if we work it out like that, if we work out the income first and then the expenditure, then we can subtract one from the other, can't we? So let's have a look at the income first of all. We know we've got 60 candles and she is selling them for £2.25 each. So then her income is going to be from sales of candles. It's going to just be 60 lots of £2.25, isn't it? Okay. So you can tap that into your calculator and work out what that is. 60 times 2.25, that comes out to be £135. 135. So that's the money she's got coming in. We need to now work out what her expenditure is. Well, that's pretty easy. That's just £125, isn't it? Okay, and then so profit is going to be income less expenditure, isn't it? It's £135 minus my £125. That leaves her with a profit of £10. Not a lot for selling 60 candles. I'd put your prices up if I were you, Shari. But we're asked here to find the percentage profit. We haven't quite done that yet. So we know that she's made £10. So her percentage profit is going to be her profit divided by her expenditure. So we can work out what percentage it was of the money that she spent. So 10 divided by 125, that comes out to be 0.08, which is 8% profit. Question 2. Hector can run 400 meters in 66 seconds. Use this information to show that he could run 5 kilometers in less than 14 minutes. So he can run 400 meters in 66 seconds. So what is his speed that he's running at then? We've been given this, which is distance travelled, and this, which is time taken. And I know a relationship between distance, speed, and time. Do you? It's a handy little little triangle: distance, speed, time. Those letters are there alphabetically. That helps you work out what the equation is that links those three quantities. Now we want speed, which is down here, look, and that tells me that it's the other two divided by each other. So speed, or average speed, is distance travelled divided by time taken. So that would be 400 meters in 66 seconds. So calculator, what's 400 divided by 66? That comes out to be 6.06. Reoccurring 060606. I'm just going to round it off to 6.06. So that is 6.06 meters per second, isn't it? That's the speed they're traveling in. So if we know that that's the speed, and I'm going to be running at 5 kilometers, how long is it going to take me to run 5 kilometers at 6.06 meters per second? So then I want to find out time. So coming back to my triangle, if I covered up time, then it would be distance over speed, isn't it? So that's my next calculation I'm going to have to do. So time is equal to distance travelled over average speed. Okay, so now the distance is 5 kilometers. My speed though is in meters per second, so I'm going to convert that 5 kilometers to 5,000 meters and then divide it by 6.06. What's that going to give me? Well, I've got the last calculated value still is the answer. I'm going to use the full calculated value by using the answer key. So 5,000 divided by answer, that's giving me 825. What unit is that going to be in? I had meters and I divided it by meters per second, so that is going to be seconds. 825 seconds. Now, what's that in minutes then? To convert minutes, to convert seconds into minutes, I'm going to divide by 60, aren't I? There's 60 seconds in a minute. So 825 divided by 60 would be what? 13.75 mins. Now that's a decimal, isn't it? So what I want to do, if it was any other sort of questions, maybe convert into minutes and seconds. But here I just need to show that it's less than 14 minutes, which I've kind of done already. So I'm just going to finish off with that then. So I can therefore say, Hector could run it in 13.75 mins. Right, and it says Hector tries to run 5 kilometers in less than 14 minutes. Give one reason why he might not be able to achieve this. Well, fairly obviously that 5 kilometers is a lot further than 400 meters, and you kind of run out of energy after a while, don't you? You know, you can't run at a sprinting speed for 5 kilometers. You've got to go at a slower pace. So what I would say here is that Hector may tire and slow down. Question 3. Here is Mario's answer to a question. So he's got a triangle here. He's got 2 sides and he wants to find a third side. And he looks like he's using some sort of Pythagoras Theorem method, because he's squared the other 2 sides and subtracted one from the other and square rooted, isn't he? The issue with this is, in this case, it doesn't work because it's not a right angle triangle. For Pythagoras to work, it needs to be a right angle. So 88 and 43, that's not going to give you another right angle at the top, is it? So I'm going to write down, he has used Pythagoras Theorem in a non-right angled triangle. So here's use Pythagoras Theorem in a non-right angled triangle. I think that's all you need to say there. Question 4. Here are the interest rates for two bank accounts. We've got Northern Saving Bank, which is 2.5% per year compound interest, and Central Alliance Bank, which is 2.7% per year simple interest. Mia puts £6,400 in each account. Calculate the difference in value between the two accounts after 8 years. Give your answer correct to the nearest penny. Okay, so I'm going to work them out separately and then I'm going to compare them then. So let's start off with the Northern Saving Bank, NSB. So working out compound interests, the final amount is going to be the original amount times the multiplier raised to the power of the number of years. That's the formula for compound interest. So what is the final is what we want to find, isn't it? Original, what's the original? It is what she put in the bank account, which is 6,400. And the multiplier is going to be 100% plus 2.5%, which comes to 102.5%, which as a multiplier is going to be 1.025, then, isn't it? So that's the multiplier we're going to use here. So my final amount is going to be my original amount, which is 6,400 times by 1.025 raised to the power of 8. Now, tapping that into my calculator because I can't do that sort of maths in my head. 6400 times 1.025 to the power of 8. That comes out to be £7,797.78. So I'm just going to write that down to the nearest penny. 7797.78. 7797.78. Okay. Now for the other bank account, that was CAB. Let's just scroll up a bit, give myself a bit more space. So let's work out the second base now, CAB Bank. Again, the final is going to be original times multiply, but I need to find them a slightly different way here. Well, the multiplier part anyway. Final is just the same, the original is just the same, still 6,400. Multiplier. Now I'm starting with 100%, and I'm going to be adding on 2.7% 8 times. So I'm just going to multiply that by 8 and work out one multiplier. So 2.7 in my calculator times 8, that comes out to be 21.6%. So add that to 100% is 121.6%, which as a multiplier is going to be 1.216. Okay, and then final amount, it's just going to be my original amount times my multiplier. Don't have to compound it this time, so I'm not raising it to a power, and I've already applied it 8 times. So it's just going to be a straightforward multiplication. So my 6,400 times 1.216, that comes out to be 6,400 times 1.216. I make that £7,782.40. £7,782.40. Okay, which you'll notice is slightly lower than the compound interest amount, which is, I suppose, the point of what we're looking at here, isn't it? So what is the difference between the two? Work out the difference between the two. So subtracting one from the other. So then the difference is going to be 7797.78 subtract 7782.40. What's that then? 7797.78 subtract answer. That comes out to be a difference of £15.38. 15.38. Okay, that's my final answer then. That's my difference to the nearest penny. Question 5. Martin buys 7 rulers and 15 crayons for, I think that's meant to read £7. A ruler costs 12 pence more than a crayon. Find the cost of 1 crayon. So if let R be the cost of a ruler and C be the cost of a crayon, then 7R plus 15C is the cost of all those things added together. And I already know that that is equal to £7, which I'm probably going to write down as 700 pence because the other costs are in pence down here. So I know that a ruler costs 12p more than a crayon. So a ruler is a crayon plus 12 pence then, isn't it? Okay, so now I've got 2 equations in 2 unknowns. Might just rearrange that second one and say R minus C is equal to 12. So they're both in the same form. So that's my equation 1. That's my equation 2. Okay, now I'm going to subtract, well, I've got a negative C and a positive C. So actually, probably what I'm going to do then is I'm going to scale this one up by a factor of 15 so that I have minus 15C. And I can then add the 2 things together. Okay, so I'm going to take equation 1, which is 7R plus 15C is equal to 700. And then I'm going to take 15 lots of equation 2. So 15R minus 15C is 12 times 15. What's that? That's 180. Okay. So now you can see I've got a positive 15C and a negative 15C underneath it. So if I then subtract those from, to add them, don't I want to add them. So I can cancel out the 15Cs, the positive and negative ones. So I've got 7R and 15R. That's going to come up to 22R. These 2 things are just going to cancel each other out when I add them together. And 700 plus 180 is 880. Okay, so I've got 22R is equal to 180. So then just need to divide both sides by 22 then, don't I? What's that going to give me? It's going to give me R is equal to, well, 22 into 88 goes 4 times, so it's going to be 40, isn't it? So R is 40p. So a ruler is worth 40p, and I know that it was 12 pence more than the crayon then. So then the crayon is going to be 40 subtract 12, which is 28. Okay, so find the cost of 1 crayon. Crayon equals 28p. Question 6. The diagram shows a cylinder and a sphere. The cylinder has a radius of 12 centimeters and a height of 30 centimeters, and the cylinder and the sphere have the same volume. Work out the radius r centimeters of the sphere. And we've been given the volume of a sphere formula handily, so we don't have to remember that. Okay, but they haven't given us the cylinder one, have they? Do you remember the volume of a cylinder formula? The volume of a cylinder is equal to, well, a cylinder is just a circular prism, isn't it? It's got a circular top there. So for any prism, we work out the area of the cross-section multiplied by its height or length. So in this case, it's going to be pi r squared, the area of a circle, times h, distance between the top and the bottom. Okay, so subbing that in, pi, I'm going to leave pi in because it's in both equations, isn't it? So they'll probably cancel each other out later. So r, which will be given as 12 squared times 30. So 12 squared is 144 times 30. Let's work that out. Could do it in my head, but 4320 pi. Okay, so I'm leaving it in terms of pi just to make it easier for the calculation. Okay, so I know what the volume of the cylinder is. Now I'm told that these 2 things have the same volume. Okay, so that's going to also be the volume of the sphere. Okay, which we're told is 4/3 pi r cubed, and I now know that that should be equal to 4320 pi. Okay, so like I said earlier, I left the pi in because look, that one is just going to cancel with that one and just leave us a few nice numbers then to work out the radius. Okay, I'm going to cross multiply. I'm going to multiply both sides by 3. That will have the effect of moving that 3 up there, and I'm going to divide both sides by 4, which will have the effect of moving that 4 down there. So I'm going to get r cubed is equal to 4320 times 3 divided by 4. Okay, so I'm going to tap that into the calculator. 4320 divided by 4 times by 3. That comes out to be 3,240. Okay, we want the cube root of that then, don't we, to find r. Okay, so if r cubed is 3240, then the cube root of that will be r. So cube root answer, that comes out to be 14.797. I'm going to round that off to just 3 significant figures. I'm going to round off to 14.8. So I'm going to say my r, my radius of the sphere, is going to be 14.8 centimeters. Question 7. The diagram shows triangle ABC. Construct a bisector of angle BAC, then construct the perpendicular bisector of AC, and then shade the region inside triangle ABC that is nearer to AC than to AB, and nearer to A than to C. So we need a straight edge and compass for this, so let's get busy with that then. Okay, first up, make sure your compass is set up correctly. You need to have the pencil tip and the tip of the compass in the same place before you tighten it up. It's a good idea to keep yourself a little stumpy pencil like this one so that you can swirl your compass all the way around without bumping into your hands. Okay. Then what we need to do is, what we've got to do, we've got to construct a bisector of angle BAC. So this is B, A, and C. So the angle BAC is this angle here. We need to cut this in half. Okay. Now to do this, you stick the compass tip at the angle, so in A, and we're going to draw an arc that cuts both those two arms of the angle. Okay, then we need to move our compass tip into that place where we cut it, and then into that place where we cut it and draw 2 extra arcs. Now those two will make a cross, and then we can then just join point A through that cross that we've made. Okay, now it doesn't matter what width you set your compass to, just that you don't move it while you're doing the construction, so you need to try and keep it the same. If you know it's moved, you probably want to stop and try again. Now, that seems to be a pretty good job. You can always check that with a protractor to be sure you've done a good job. Alright, next, construct a perpendicular bisector of AC. This is AC, so we want to cut this line in half. Now to do it, we need to set our compass so that it's slightly more than half the distance between the 2 points. Between half and 2/3 of the line is a good distance. Okay. And then we're going to draw 2 arcs from C and from A, and then hopefully they'll cross. I'm going to struggle a bit because it's going off the bottom from my paper here. So bear with me. Okay, so there's one of the arcs. Now move the point over to A and draw the second arc. Okay, I haven't quite got the cross at the bottom there. Let me just extend that one a little bit. Okay, there we go. So then those 2 arcs make 2 points of intersection, which you can then join up with your ruler. Okay, oh, I've got my ruler the wrong way around. You can see it's an awesome Pokemon ruler today. Okay, so there's my second line. So we want to shade the region that is inside triangle ABC that is nearer to AC than to AB. So nearer to AC than to AB is going to be below this angle bisector then, isn't it? And nearer to A than to C is going to be the left-hand side of this perpendicular bisector. So the area that we want is this triangle in here. So it's below the angle bisector and to the left of the perpendicular bisector. All done. Good job. Question 8a. Two numbers p and q are written as products of their prime factors. We've been given p, which is 2 to the power 5 times 3 squared times 5 cubed times 11. And q, which is 2 to the power 4 times 3 times 5 to the 4 times 7. We need to find the lowest common multiple, the LCM of p and q. Okay. Now there's one way of finding the LCM, which is just to kind of list like all the numbers in each number's times table and find the one that's common, the smallest one that's on both lists. But that's going to be long for these big numbers, and it's not really how this one is intended to be solved. We're meant to be using these products of prime factors to do it. So I'm going to just write out the two numbers again. I'm just going to leave a space there because I haven't got a 7. I'm going to write the 11 a bit further along like that. And then underneath it, I'm going to write q. Just lining up these powers. Okay, so let's write that 7 again. It came out horrid. Okay, so you can see that my p has got factors that include 2, 3, 5, and 11, and q's got prime factors that includes 2, 3, 5, and 7. Okay, now the LCM of these two numbers is going to be every number that occurs, every base that occurs. So I've got a 2, I've got a 3, I've got a 5, I've got a 7, and I've got 11. So each of the bases that appear in either numbers will feature in your LCM. So I'm going to have a 2 in it, I'm going to have a 3 in it, I'm going to have a 5 in it, I'm going to have a 7, even though there's only one 7, and that's in Q. And I'm also going to have 11 in it, even though there's only one, and that's in P. So each of the prime factors that appear in either P or Q appear in the LCM. Okay, and then we have to scan through and find the highest power of each number. So P has got 5 2's and Q's got 4 2's, so the highest one there is the 5. So my LCM is going to be 2 to the power of 5. Okay. P has got 3 squared, Q's just got 3 on its own, so the highest power of 3 that's appearing is that one there, the squared one. So I'm going to have 3 squared. Then I've got 5 cubed and 5 to the 4, so I hope you're getting the hang of this now. So the highest one that appears in either of them is the 4, so it's going to have 5 to the 4. Okay, now the 7 only appears in Q, and it's just a single 7, so it's just 7 by itself. And again, the 11 only appears in P, so the highest power it appears is just 11 to the power 1, or just 11. And that is then our LCM. Okay, so just multiplying all those things together. 2 to the power 5 times 3 squared times 5 to the power 4 times 7 times 11. That comes out to be a huge number, 13,860,000. Okay, is that right? Appears to be. So that is probably why you didn't want to then list all these numbers. You'd have been there until Christmas, wouldn't you? Listing all those out. So I'm just going to copy it down, make sure I've got the right number of zeros. So 13,860,000 is the LCM of those two numbers. Okay. So if you were listing them out and one out and then the other out. Whew. Part 2 says the number C is written as a product of its prime factors, and C is 2 to the power 3 times 3 times 5 squared. Work out P divided by C, leaving your answer as a product of powers of prime numbers. Right, so P divided by C is what we're after then, isn't it? P divided by C. Now we know P, we've given it in the last question, so that's 2 to the power 5 times 3 squared times 5 cubed times 11, and we're going to divide that by 2 cubed times 3 times 5 squared. Okay, So we've got numbers with the same base, which we're going to divide. So we're going to subtract the indices. So that 3 is going to be subtracted from that 5, leaving 2. That 3, there's one of them, isn't it? Subtract there from there, leave you with 1. And if I subtract these 2 5s from these 3 5s, it'll leave me with 1 5. So the answer is just going to be 2. So the answer is going to be 2 squared times 3 to the power 1, which is just 3, times 5 to the power 1, which is just 5, times 11. Okay, that's it. Question B, part 1. Write 450 as a product of its prime factors. Now this is going to be the easiest 3 marks on the paper if you've got yourself a Casio calculator. And if you don't, it's a very good reason why you should rush out and buy yourself one this side of the exams. Just for this one feature. It's the fact button on the calculator. So if you pull up your calculator, it's a Casio one, and you type in 450 and press enter. So it kind of makes 450 the last calculated value. Next we just press shift and then that fact key, and it's going to rewrite 450 as a product of its prime factors. 2 times 3 squared times 5 squared. So 450 is 2 times 3 squared times 5 squared. Super easy. If you haven't got one of these calculators, go and buy one, or you might have to do it the long way, which is finding factor pairs that multiply together to give you your number. So 450 could be 9 times, what's that, 9 times 50. Neither of those are prime, so we break them down. 9 is 3 times 3. They're both prime, so you can stop there. 50 is what? 5 times 10. Okay, 5 is prime, so we can stop, but 10 isn't. That's 2 times 5. Okay, and then well, that's all our answers then. So the 2 there is that 2. Then I've got 3 and 3, which gives me 3 squared. And I've got 5 and 5, which gives me 5 squared. Okay, so you can either do it the long way with the tree, factor tree, or you can do it the smart way by yourself a Casio and do it much easier. Part 2 says find the highest common factor, or HCF, of 270 and 450. Now again, I could find all the factors of 270 and 450 and then see which was the biggest number on both lists. Or I can do this one again using prime factor decomposition. So I already know that, which is why I'm going to demonstrate here. So I already know that 450 is 2 times 3 squared times 5 squared. It was my answer from the last part of the question. Okay, I'm going to do the same thing with 270. So I'm going to type that into the calculator. 270 equals, and then pressing the factor key will break that number down to a product of its prime factors. It's 2 times 3 cubed times 5. Okay. Actually, it's sometimes it's a bit easier to see this if it's in expanded form rather than in factor form like this in index form. So let's just multiply that out. So I've got 2 times 3 times 3 times 5 times 5 times 5. And on the second one, I've got 2 times 3 times 3 times 3 times 5. So then my HCF I can find by looking at things that appear in both lists that go together. Okay, so I've got a 2 here matching up with a 2 here. I've got a 3 here that matches with a 3. I've got another 3 that matches with a 3. I've got a 3 on its own, nothing to match it with, and I've got a 5 that matches up with a 5, and I've got a 5 on its own that I can't do anything with. So all the ones I ringed are going to be part of the HCF, which is 2 times 3 times 3 times 5. Okay, so that's how you do it with the product of prime factors. So what's 2 times 3 times 3 times 5? 2 times 3 is 6. 3 times 5 is 15. 6 15s are 90. It's going to be 90, isn't it? So I really can't stress enough the importance of having a decent calculator for your exams. I highly, highly recommend the Casio ones. Like I say, if you're just doing GCSE Maths this year, and you're not carrying on with A level, then I recommend you getting the FX85 GTX or the 83 GTX. But if you are staying on for A level maths next year, pay a little bit more now and upgrade to the Casio Class Swiss. The FX991EX is the one you're looking for. Cost about £20 rather than £10, but it's packed full of extra features that will be helpful at GCSE, but more importantly, you can go on to use it at A level. Okay, so that's the one I'd recommend if you're carrying on with A level maths next year. Okay, links to all these in the description below, or follow the link to my Amazon shop for more details on recommended calculator and revision guides. Question 9. 72 children are asked whether they have a laptop or an iPad. We're told that 31 have a laptop, 48 have an iPad, 12 have both, and 5 have neither. Represent this information on a Venn diagram. Okay, so we're going to have two ovals, aren't we? Okay, oval 1, oval 2 that overlap. Okay, going to label them laptop and iPad. Okay, set L, set I. So 31 have a laptop, 48 have an iPad, 12 have both, 5 have neither. I'm going to start with the both and neither. So both is the ones in the middle, isn't it? So there's 12 in there, and 5 have neither. That's on the outside. Now you might think that you can just write the 31 here and the 48 there, but if you add up 31 plus 12 plus 48 plus 5, you'll see it comes to more than the 72 children that you have got. So we're not writing 31 and 48 there. What we need to do is just to make sure we've included these 12 students here in the middle. So if 31 have a laptop and 12 have both, that means that 31 subtract 12, which is 19, have a laptop only. So 19 and plus the 12 make you 31. Okay, and on the other side, iPads, if 48 have an iPad and 12 have both, then just an iPad is going to be 48 subtract 12, which is 36. Okay, so then if you add up those four numbers, 19 plus 12 plus 36 plus 5, you'll see that that does come to 72. Okay, so there we go, that's that bit. Part B says one of the children is chosen at random. Write down the probability that they have an iPad but not a laptop. Well, the probability of iPad not laptop. Well, it's successful outcomes. How many have an iPad and not a laptop divided by total outcomes, which is how many students there are altogether. Okay, now there are 72 students altogether, so that's the number on the bottom. And if you remember, if you look back at our Venn diagram, you'll remember that we had 36 students who had iPad only, because we had to take off the 12, didn't we? Off the 48 to find out how many had iPad only. So that is the number I'm going to write at the top of my fraction here, which is 36 out of 72. Now, you can cancel that down if you want to, but you never get any extra credit for probability questions for cancelling down the fractions. So you might as well just leave it like that. Okay, but if you do cancel it down and get a half, go you. You've just wasted 3 extra seconds of your life. Right, let's move on. Question 10. Here is the graph y equals x squared plus x minus 6. Use the graph to solve the equation x squared plus x minus 6 is equal to 0. Okay, well, first off, notice that this expression here, x squared plus x minus 6, is the same as up here. So if we're saying this is equal to 0, basically what we're saying is find when y is equal to 0. That's what we're looking for. Now, y is equal to 0 is the equation of the horizontal line passing through 0. In other words, it is the equation of the x-axis. So y equals 0 is the x-axis. So what you're trying to do is you're finding the places on the graph where the graph crosses through that x-axis, which is there and there, isn't it? Okay. So we're going to have two solutions to this because it's a quadratic. One solution is just going to be x equals minus 3, the left hand intercept, and the other one x is equal to 2 is the right-hand intercept. Okay, so these are often called the roots of the equation, aren't they, where it's equal to 0. And that's how you find them on a graph. So just look along the x-axis where the graph crosses the x-axis and you will find the roots. X equals -3, x equals 2. Question 11. Here are two functions. I've got function A, which is a two-step function machine. It's a times 2 add 4 function. And B is a subtract 1 times 3 function. The composite from function C is shown below. So input, go through function A, then go through function B, and then that is your output. And we're told the output from function C is 54. Work out the input. Okay, so we know that this output here is 54. We want to work out the input over here. Now function B, so this bit here is this function, isn't it? Okay, that's all what we've got there. That's all function B. So actually the 54 is what we get coming out of the B function then, isn't it? Okay, so if 54 came out of this function machine, what must have gone into it? Well, basically what's here first off? So 54, something times 3 is equal to 54. What was it? Well, if I take 54 and I divide it by 3, 54 divided by 3, that's 18. So that number there then is 18. Okay. Then if I had a number and I subtract 1 from it, I got 18. I must have got 19 to start with. So 19 subtract 1 is 18. So that means 19 was fed into function B, which is then here on my graph. Okay, then if I want to then work out what the input of function C was, I then next need to take into account function A, don't I? So here's function A over here. Okay, so we know that function A spat out the number 19. And what we want to do is work out what the number that went into function A was. So we're going to do the same thing, going to work backwards through function A now. So I had a number, I added 4 to it, and I got 19. So that there must be 15. Okay, and then I had a number, and I multiplied it by 2, and I got 15. So 15 divided by 2, that is 7.5, isn't it? So 7.5 is the number that I fed into A, which was then fed into B and then came out to be 54. So what was the input? The input was 7.5. Part B says the input to function C is x. Find the expression in terms of x for the output from function C. Okay, so going back to our functions that we had earlier. Now, what we're saying is if I feed, let's just change pen color. So if I feed x into this function, what do I have come out the other side on y? That's going to be my output there. What is that value? Okay, well, if I put x into function C, it's going to be fed through function A first. So if I feed x into function A, it's going to be multiplied by 2 first. That's going to give me 2x. And then I'm going to add 4. So that's going to give me 2x plus 4. Okay, so that is the output from function A, 2x plus 4. Next off, I need to take that 2x plus 4 and plug it into function B and see what I get come out the other side. So if I feed 2x plus 4 into this function machine, the first thing I'm going to do is subtract 1 from it. So 2x plus 4 subtract 1. If I take 1 away from 2x plus 4, it's just going to leave me with 2x plus 3, isn't it? Then I'm going to take my 2x plus 3 and it's going to get multiplied by 3 in the second part of function B. So 3 lots of 2x plus 3. Well, that's just 3 lots of 2x plus 3. I'm going to write in brackets there because I need to multiply the all of 2x plus 3 with 3. And that's my answer, 3 lots of 2x plus 3. 3 lots of 2x plus 3. Question 12. 30 students completed a puzzle and their times were recorded. All of the students completed the puzzle in less than 50 seconds. The histogram shows information about some of their times. And it says complete the histogram for those completing the puzzle in less than 10 seconds. So basically there's a bar missing here, isn't there? We've got the people who complete between 10 and 25 seconds, between 25 and 35 seconds, and between 35 and 50 seconds. What we need to do is work out this missing bar in here. Okay, so how many people do the 3 bars that we've got represent? Because if we can work out these 3 amounts, we know that there are 30 students altogether, so then we can subtract those 3 bars from 30, and it should leave us with the amount of people to represent in bar 1 then, doesn't it? Okay, so if you remember with histograms, it's the area of the bar that represents frequency. So in this first bar here, it's got a width running from 10 to 25, so it's got a width of 15. Its height is here, look, 0.8. Okay, so then this bar represents those 2 numbers multiplied together then, so 0.8 times 1.5, sorry, 0.8 times 15, isn't it? Not 1.5, 15. So 0.8 times 15, that comes out to 12 people. So 12 people represented in this first bar. In the second bar, the width from there to there, it's running from 25 to 35, so it's got a width of 10. Its height is 0.9, isn't it? So this one is going to be 0.9 times 10. Well, I know that one, that's just 9, isn't it? So that was 9. And then finally, this other bar down here, this has got a class width of, what, 35 to 50? It's got a class width of 15. It's got a height of 0.2, so 0.2 times 15. It's 3, isn't it? 3. So our bar we've got to add is going to be our 30 students less the number represented in the other 3 bars, the 12, the 9, and the 3. So all this is telling me that the frequency of that first bar between 0 and 10 is going to be 30 subtract 12 plus 9 plus 3. 12 plus 9 plus 3 is 21, 24. 30 to subtract 24, that's just 6, isn't it? So I've got to represent 6 people in this bar. Now, the width of the bar goes from, well, you can see it goes from 0 to 10. So our class width then is going to be, it's just going to be 10 subtract 0, or 10, which means the frequency density is frequency 6 divided by class width 10, which gives me a frequency density of 0.6. So I'm going to have to draw my bar then of a width 10 going from 0 to 10 and a height of 0.6. Okay, so just going to turn auto shape on and cheat. So my wonky bar turns into a nice neat one. There we go. And then just shade it so it's a bit clearer. Okay, so that's the bar I needed to add. Height of 0.6, width of 10. Question 13. Tenzin is given this equation. Factorise fully 2x squared plus 6x. Here is its answer. 2x squared plus 6x, that's equal to x 2x plus 6. Explain why Tenzin's answer is not correct. Okay, well, he's partially correct. He has factorised it. He's found a common factor of 2x squared and x. He said there's an x in both, and he's factorised it out and put it at the front there. X times 2x is 2x squared, and x times 6 is 6x. So he's not wrong, but he's not right either, because he's missed out this second word, factorise fully. He's found a factor. He hasn't found all the factors of 2x squared and 6x. X is a factor, but so is 2. 2 goes into 2 and 2 goes into 6. So 2x is what he should take out. So 2x taken out of 2x squared, that leaves x. And 2x taken out of 6x, it leaves me with 3, doesn't it? So 2x times x is 2x squared, 2x times 3 is 6x. Okay, so you should have factorised it like that. So I think probably just writing down the true answer like that should be enough. It should be 2x, x plus 3. But you might get away with just saying he hasn't factorized it fully. It's only a 1 mark question. It's hard to know exactly what's the minimum requirement for getting that mark. So you might be able to get away with saying, oh, it's just not factorized fully, but writing down what the correct answer is definitely going to get you the mark. Question 14, y is inversely proportional to the square of x, sorry, the square root of x. Y is 40 when x is 9. Find the formula linking x and y. Okay, so very bog standard, straightforward proportionality question. This first thing here tells me the relationship between y and x. So y is inversely proportional to 1 over the square root of x. Root of x. So y is proportional to 1 over root x. Okay, that's the relationship between y and x. Now I can replace the little fishy symbol or the proportionality symbol with equals k. So k times 1 is just k over root x. So the equation is going to be of that form, y equals k over root x. Now they always then give you a pair of numbers that go together, and the reason they give you that is that you can then evaluate your value of k here and find the complete equation. So we're going to do that bit next. So when y equals 40, x is equal to 9. So we're going to plug those two numbers in. So 40 is equal to 9, sorry, is equal to k over root 9 then, isn't it? Okay, square root of 9 is 3. Multiplying both sides by 3, you're going to get k is equal to 120. Okay, so once I know that k is 120, I can then complete my equation. And so complete formula is y equals 120 over the root of x, like that. That's the complete formula. Okay, so very, very standard. They give you the relationship, they give you a pair of values to work out what k is, and then you do that, and then you write down the complete formula for the 3 marks. Question 15, the box plot shows the distribution of the runs scored by David in some cricket matches. And then underneath the box plot, we've got some extra information for Peter's scores. And we need to show the distribution of Peter's scores as a box plot on the diagram above. Okay, so we need to add his box plot underneath the box plot we've already got. Okay, so now the middle line of a box plot, that is the median. We sometimes call that Q2, the median. Either end of the box is Q1 and Q3. There are a lower and upper quartile, and then that is the least and most, or the highest and lowest values of your box plot at the end of the whiskers. So first off, we're told that the median score is 26. So for Peter then, I'm going to have a line at 26. So if that's 20 and that's 30, there are 10 divisions in between. Just need to count up. 1, 2, 3, 4, 5, 6. 26 is going to be there, isn't it? Okay, so just going to draw a line there at 26. Okay, the highest score is 39. I'll come back to the highest and lowest. They're the whiskers. I'm going to go to the quartiles. The lower quartile is at 14. So 10, 11, 12, 14 is there. The interquartile range is 18. So the interquartile range is the distance between the lower quartile and the upper quartile. So if the lower quartile is at 14, then Q3, the upper quartile, is going to be 14 plus the interquartile range, isn't it? So 14 plus 18 takes me up to 32. So I'm going to have an upper quartile at 32. Okay, so I've got my 3 lines that make up the box of the box plot. So let's just finish that bit off. So there's my Q1, the lower quartile, Q2, the median, and Q3, the upper quartile. So then all I need to add to my diagram now is the lowest score and the highest score. So it's got the lowest score of 8. So 10, 9, 8 is there. and the highest score is 39, so one less than 40, it's up here. Okay, and I just draw my whiskers in now then, that go from the least to the highest value. Whisker. Whisker. Okay, so that's my box plot. Don't have to do anything with it. That's it, can move on. Part B is where we have to start thinking about what these values mean. Part B says, decide whether David or Peter best satisfies each of these questions. Give a reason for each of your decisions. Firstly, who scores the most runs on average? Okay, so if you have a look at the two box plots, then the most runs on average is going to be your average or your median score. That's the Q2 score, isn't it? So there's the Q2 for David. His median is 16. And then the median for Peter, much higher. It's this one here, isn't it? So that was 26. So David's median is 15. Peter's median is 26. So clearly Peter has more runs on average. Okay, so my answer is going to be who scores the most runs on average? It's Peter, because his median is higher than David's, and I can put in brackets what it was, 26 versus 16. Okay, now the second part of the question says whose scores was the most consistent. Well, for consistency you want a measure of dispersion, and the only measure of dispersion we have here is the interquartile range. So you can see from, well, we're given the interquartile range for Peter, weren't we? It was here. The interquartile range was 18, and well, we can work out the interquartile range for David. It's the distance from Q1 up to Q3 there, isn't it? So his upper quartile is 21, and his lower quartile is 12. So his interquartile range is going to be 21 subtract 12, it's 9. Okay, so his interquartile range is 9. Peter's is 18. So David is the more consistent player, isn't he? Because his interquartile range is smaller. So my answer is, whose score is more consistent? David, because his interquartile range is smaller than Peter's. And that was 9 versus 18, if you remember rightly. Okay, so that's it. Question 16. Solve by factorization. 2x squared minus 19x minus 33 is equal to 0. Okay, so when you are factorizing a quadratic, if it factorizes, you nearly always get two brackets like this. Okay, and the number that goes here and here is two numbers that multiply together to give you that minus 33 there, doesn't it? Okay, now what are the factor pairs of 33? There's not that many, are there? There's 1 and 33. So 3 and 11. 3 times 11 is 33. That's it, isn't it? So you just got those possibilities, 1 and 33 and 3 and 11. Now before I put them in, let's have a look at the other end of my equation, this 2x squared part. If I've got 2x squared, it must be that I've got a 2x at the start of one of my brackets and an x at the start of the other one. So when they're multiplied together, it gives you the 2x squared. So if you've got a coefficient of x squared like this, it makes it a little bit more complicated when you put these factor pairs of 33 in, because it makes a difference which way around you put them in. So you've got to try them in both positions. So this 1 and 33 to start with, I could put the 1 there and the 33 there. So I'd end up multiplying the 2x by 33 to give me 66, and 1 times x would give me just 1x. So I get 1x and 66x. their difference is going to be 65 is much too big. Okay, so if we try it the other way around though, so if I put the 33 here and the 2, sorry, and the 1 this side, so I'm going to get 2x times 1, which is going to give me 2x, and the 33 times x is going to give me 33x. 33x take away 2x is 31x, is still too big, so it isn't 1 and 33. Okay, so let's try the other two numbers, 3 and 11. Could put the 3 there and the 11 there. 2x times 11 is 22, 3 times x is 3x, so 22x take away 3x is 19x, isn't it? So that one works, and it wouldn't work the other way around. I'm just going to show you. If I put the 11 here and the 3, I'm going to get 2x times 3, which is going to give me 6x, 11 times x, which is going to give me 11x, and the difference between 11x and 6x is 5x, not 19x. It doesn't go that way around. So I know that the 3 goes in the first bracket, and the 11 goes in the second one. Okay? Signs, it's negative, so it was 1 plus 1 minus. I've got minus 19x, which kind of makes me think it's the bigger number of the two that's going to be negative. So 2x times negative 11 is negative 22, plus 3x is going to be negative 19. That fits, doesn't it? Okay, so it factorizes to 2x plus 3, x minus 11 is equal to 0. Okay, not done yet. I need to solve. So I need to find the values of x, don't I? So when we've got two things multiplied together and equals 0, it means one of those two things must be 0. So that must be 0 or that must be 0. Okay, well, the second one is easy. That means x is 11. The first one, 2x plus 3 is equal to 0. That means 2x equals minus 3. X is minus 3 over 2. So they're my two solutions then. X is minus 3 over 2 or x is 11. Question 17. Here are the first 4 terms of a quadratic sequence. I've got 2, 15, 34 and 59. The nth term is a n squared plus b n plus c. Find the values of a, b and c. Okay. With quadratic sequences, it is the second difference that you're interested in. If you look at the first difference between these two numbers, 2 to 15 is plus 13. 15 to 34 is plus, what is it? 19. And then 34 to 59 is plus 25. Okay, so you can see that what we're adding on each time is going up. But if you look at the second difference, 13 to 19, that has a difference of plus 6, and 19 to 25 has a difference of plus 6. So it has a common second difference of plus 6. That is important. That tells us that the a term is going to be half of that value. Basically, it's going to be a is equal to 3. So a is equal to 3. So that's going to give me my 3n squared part. So this quadratic sequence is made up of 3n squared plus this linear part here, bn plus c, which we still need to find. Okay. Now, 3n squared, when n is 1, when n is equal to 1, then 3n squared is going to be 1 squared times 3. It's going to be 3, isn't it? When n is 2, then 3n squared is going to be 2 squared. 4 times 3 is 12. When n is 3, 3 squared is 9 times 3 is 27. And when n is 4, then 4 squared is 16 times 3, 16, 32, 48, isn't it? Okay. Now, that's what I get for 3n squared. Now, the sequence I was actually given was 2, 15, 34, and 59. Okay, now we want to work out the difference between the two because we're looking for the bn plus c part next. Okay, so if I subtract those, what's it going to leave me? 2 subtract 3 is minus 1. 15 subtract 12 is 3. 34 subtract 27 is 7. And 59 subtract 48 is 11. Now, you probably spotted already, this is a linear sequence. It's going up in plus 4s. Okay, this is what we expected. So if it's going up in plus 4s, that means my b part then is going to be 4. Okay, so my bn is 4n. So 4n is, if n is 1, 4n is 4. If n is 2, 4n is 8. If n is 3, 4n is 12. And if n is 4, then 4n is 16. Now if we compare that to what we've got, we don't have minus 1, 3, 7, 11. We've got 4, 8, 12, 16, which has got a difference of 5. Each of the numbers in our sequence was 5 less than what we've got. So 4n subtract 5 is going to give me what I want then, isn't it? 1, minus 1, 3, 7, 11. Okay, so the linear part of my sequence is 4n minus 5. So that means that c then is negative 5. Okay, so we found all 3 bits. A is 3, b is 4, c is negative 5. So the nth term, not they asked us for this, but is 3n squared plus 4n minus 5. Okay. Question 18. P is the point 0, minus 1, and Q is the point 5, 9. Find the equation of the line through P that is perpendicular to the line PQ. Okay, now this is a coordinate geometry question, which is shape and space. And I think any shape and space question that you do, you should really have a diagram that goes with it. Now, they haven't given you one here, so I think it's always worth just doing a quick sketch and writing down what we know on the diagram to make it a little bit more clear for ourselves. So we've been given the 2 coordinates of P and Q. So I'm just going to quickly draw those on a sketch. Okay, so the coordinate P is the point 0, minus 1, which is going to be a point on the y-axis then, isn't it? Because it's got an x-coordinate of 0. And the next one is at 5, 9. So up here, that's going to be Q. So that's 0.59, and I've got P down here, which is 0, minus 1. Okay, so then if I draw a line between them, that is the line PQ. So that's PQ. Now what we want is the line through P, which is perpendicular to the line PQ. So we've got to draw the one that's at right angles to that line. Okay, so what's that line going to look like? It's going to look like this. Okay, that's the line we're trying to find. Okay, so it's a slopey down line. We're expecting a negative gradient, and we already know some things about it. We already know its y-intercept. We know where it crosses the y-axis. It's there, look. So we know quite a lot about it already. Okay. Now, what we need to do is just work out its gradient. We already know its y-intercept. So to find the equation of a straight line, they're always the form y is equal to mx plus c, where m is the gradient, c is the y-intercept. Like I say, we've already found c. It's at -1. We want to find out what m is. Now, we don't know anything about well, we've got 1 point on P, on the line we're looking for. We've got the point P, but we can't find the gradient from just 1 point. But we do know 2 points on Q, and we know that the line we're looking for is perpendicular to it. So let's find the gradient of PQ first. So gradient of PQ, which I'm going to call M1, is going to be change in y, or the y coordinates. If I call this one x1, y1, x2, y2, then the gradient function is y2 minus y1 over x2 minus x1. Have you seen that formula before? Hopefully you have. So subbing in, basically what you're doing is just trying to find the change in y and the change in x between these 2 points. So I've got 9 subtract -1 for the change in y, divided by 5 subtract 0 for the change in x, which is what? 9 subtract -1 is 10. 5 subtract 0 is 5. It's got a gradient of 2. Okay, so the gradient of our line then, which is perpendicular, so the gradient of the perpendicular line, M2, is going to be -1 over M1. It's a negative reciprocal of your perpendicular line, which is -1/2. So the gradient of our perpendicular line is going to have a gradient of -1/2, which is what we were expecting. We were expecting it to be negative. So then the equation of my line is going to be y is equal to the gradient, which we found to be -1/2, x, plus the y-intercept that we already know is -1. So it's y equals -1/2 x minus 1, because we already knew that c was -1 from the diagram. Okay, and that's the complete equation. We found it. Question 19. Two cylinders A and B are mathematically similar. Cylinder A has volume of 2,400 cubic centimeters and a height of 12 centimeters, and cylinder B has a volume of 750 centimeters cubed. Find the height of cylinder B. Give your answer correct to an appropriate degree of accuracy. Again, we've got a shape and space question and no diagram. So for me, first thing I'm going to do is quickly sketch what I've got. Okay, so I've got big cylinder equals cylinder, okay, which are mathematically similar. I know that this one is 2400 and this one is 750, and this one has a height of 12, and this one is got a height that I'm trying to find, so I'm going to call it H. Okay, so I've got my two diagrams. Okay, now when you've got two mathematically similar shapes, then the ratio of their lengths and areas and volumes are all related, aren't they? So the ratio of their lengths, let's say it was x to y, then the ratio of their areas is going to be x squared to y squared, and the ratio of their volumes is going to be x cubed to y cubed. Okay, so we've got, well, we know the ratios of their volumes because we've got the values we've got there. We've got 2,400 and we've got 750. Okay, so if we cube root both those numbers, we should be able to find the ratio of their lengths. Now let's just make this a little bit easy to calculate with. If we divide both sides by 750, then I make this second one 1, don't I? So 2,400 divided by 750, according to my calculator, is 3.2. Okay, so the ratio of their volumes is 3.2 to 1. Okay, so that means that the ratio of their lengths is going to be the cube root of 3.2 to 1, isn't it? So cube root of 3.2 to 1, cube root of 1 is just 1. So the cube root of 3.2, again according to my calculator, is 1.47 to 1. I'm just going to keep the full calculator display value for now though, because I need to use that. This is going to be the length, isn't it? The ratio of their lengths. It's going to be 1.47 to 1. So if I then take 12 and I divide it by our cube root of 3.2, I should be able to find the height of our second can then. Okay, our second cylinder. So 12 divided by my previous answer comes out to be 8.14. Okay, so what would be an appropriate degree of accuracy? These numbers up here are quoted to 2 significant figures, each of them, aren't they? So I'm going to round this one off to 2 significant figures as well. I'm going to say that that is 12 to 8.1. Okay, so my height then is 8.1 to an appropriate degree of accuracy, 2 significant figures, the same as the other in the question. Question 20. The diagram shows a right-angled triangular prism ABCDEF, and we are asked to calculate angle AFB. Okay. Well, here's A up here, here's F down here, and here's B all the way back over here again. So where is angle AFB? It's hard to see in this diagram from the offset. I think I need to add some extra lines in just to make it a little bit clearer. So I'm going to draw a line from A to F and then from F to B so we can see this angle a little bit clearer. Let's use green. Okay, so just drawing those lines in. Okay, I need to find this angle down here then, don't I? Okay, which I'm going to call theta, for want of a better word. Okay, so in order to find that angle, I'm going to need to know two things in triangle ABF. At the moment, I know one thing. I know that this side here is 18. I also know it's a right angled triangle. There's a right angle down here, but I need to know one other thing if I'm going to use trigonometry to find that angle theta down in the bottom corner. So before I can work out that angle there, I'm going to need to find another side in triangle ABF. And what I'm looking at here is probably this line here, along here. If I can find that triangle, that length first, then I will know two things in triangle ABF, and then I can use those two things to find the angle. Okay, so how am I going to find BF then? Well, BF lies in, well, it's part of triangle BCF. So if I draw this triangle in, so the base of this prism, halved it, and then I've got BCF, which is a right angle triangle. So the right angle then is here, isn't it? That's the right angle. And I know two of the sides, so I can use Pythagoras Theorem in that triangle to find BF. And once I've got BF, I can use trigonometry in ABF to find the angle. So that's my plan of attack. Okay, so we're going to use one triangle at a time. So I'm going to say in triangle, it's a quick way in maths of writing triangle, just draw a triangle. So in triangle BCF, I often find it's handy just to quickly sketch what that triangle is. So you've got a smaller diagram to work on. So this is the right angle here at C. That's F. That's B. That was 25. And that is 40. So I want to find BF. Okay, so BF is what I want to find. Now that squared is equal to the sum of the squares of the other two sides, isn't it, using Pythagoras Theorem. So that's going to be 25 squared plus, because it's the longest side, plus 40 squared. Okay, so I can work that out first. So calculator, what is the sum of 25 squared plus 40 squared? 25 squared plus 40 squared. That comes to be 2225. 2225. So then BF is going to be the root of that then, isn't it? So root answer comes out to be 5 root 89. I'm just going to write it down like that for now. In fact, I might just leave it as that. Let's just leave it like that. Because I'm going to be using it in the second calculation anyway. And if I work it out and write it down as a decimal, I'm going to be losing accuracy. Whereas if I leave it as root 2225, I retain all the accuracy. It's a exact answer. So it's better to use that one. Right, okay, so we've got BF, and now we can switch to the other triangle. So in triangle, what we got now? ABF. Okay, and again, I'm going to quickly sketch that. So A, B, F, A, B, F. The right angle is down here. That's the angle then at F that I'm trying to find. That's my theta. And I know that AB is 18 centimeters. And I now know that BF is root 2225 then, don't I? Okay, and then I want to work out what that angle is down here. Okay, so I'm going to use trigonometry. So here's my angle. So this is the opposite, this is adjacent, this is the hypotenuse. So we're interested in the opposite, because I know that one, and the adjacent, because I know that one, and I can use that to find tan, isn't it? Sorry, I use that to find the angle. So pulling up our mnemonic, SOHCAHTOA, SOHCAHTOA, work out which one has got the opposite and the adjacent, and I think I might have already said that it's that one, tan. write down the full ratio. Tan theta is equal to the opposite over the adjacent. Substitute in, so tan theta is equal to 18 over the root of 2225. So then theta is going to be the inverse tangent of that then, isn't it? So theta is going to be tan to the minus 1, 18 over 2225 rooted. Okay, what's that? Calculator, what's the answer? So I'm going to press shift tan to find the inverse tan. 18 divided by the root of 2225, close bracket, oops, close bracket. That comes to 20.886162. I'm going to round that off. Just going to write down the first three significant figures, which is 20.9. And it's degrees, isn't it? Because it's an angle. Okay, 20.9. Question 21. The number of gannets on an island is assumed to follow the exponential growth model. N equals 0.45 times 1.07 to the power of x. It's a little bit like compound interest. It's interesting we've had a second question on the same topic here. N is the number of gannets in thousands. X is the number of years after the 1st of January 2010. Complete the table for N. Okay. Now, again, if you've got one of these nice Casio calculators, you can use the table function in here to work out what all the values are in these missing tables. It's quite handy. I'm going to quickly show you how to do it. So click menu, select the table option. Now the first thing that pops up is f of x. Now this is the function that you need to be putting in. Okay, so here I'm going to type in the bit after the equal sign. So it's going to be 0.45 times 1.07. Use the power button, and then up there I need to write the x. Now the x, you can see, is written in red above the right bracket. So to access it I need to press the alpha key, and that should pull up my x. Okay, so I've written in my function f of x, and it's what n is equal to in the paper. Right, when I press equals, if you've got the newer Casio model, you'll get an option for g of x. If you've got the older one, it will just skip over g of x. You can only put one function in. I'm not going to use the second function, so I'm just going to press equals again. Then it asks me start, end, and step. I'm going to be starting at 0 because that's my lowest value of x in my table. I'm going to be ending at 20 because that's the highest value of x in my table. And you notice the values in x are going up in 5s. So that's what the step is what you're going up in. So I'm going up in 5s. So if I press equals again, you should see it then generates a table for me. The first column has got my x values. You see it's got 0, 5, 10, 15. And if I scroll down, I'm going to get the next ones as well. And next to it in the f of x column, I've got the values of the function. Now you should be reassured to see that the first two match up. So I've got 0.45 for 0. I've got 0.63 and a bit more detail for 5. At 10, I've got 0.8852. So all these numbers are rounded to 2 decimal places. So I'm going to do the same thing. I'm going to round off that. I'm going to write in 0.89 under there for 10, 0.89. And then I got my 15 value. You should be reassured again that matches up with the one that's in the table. And then finally, I've got my 20 value, which is 1.74. I'm going to write that in, 1.74. Okay, job done. Thank you, calculator. Again, highly recommend you get a Casio calculator that looks like this one if you haven't got one already. And as mentioned before, there is a link below to my Amazon page where you can find this calculator and other recommended stuff for your exams. Okay, in part B, I need to plot these points then. So let's just have a quick look at the scale. from 0 to 0.5, I've got 5 little squares. So each one of these divisions is 0.1, isn't it? So that'd be 0.1, 0.2, 0.3, and so on. Okay, it's important that you understand the scale before you start plotting points. Okay, so the first point I need to plot is 0 against 0.45. Okay, so 0.4 is here, 0.5 is here. The point I want is halfway between them, isn't it? Okay, so a little point there, halfway between 0.4 and 0.5. At 5, I need to plot 0.63. So 0.6 is here. 0.63 is going to be a third of the way between 0.6 and 0.7, isn't it? So a little cross there. 10 goes with 0.89. 10, 0.89, that's almost 0.9, isn't it? I'm just going to plot it at 0.9, I think. And then 15 goes with 1.24, which should be halfway between 1.2 and 1.3 then, shouldn't it? So it should be, lines are going, losing track of my lines. Should be there. Okay, and then finally 4. So finally 20 goes with 1.74, which is going to be halfway between 1.7 and 1.8, isn't it? Okay. Now you should see these form a kind of a curve. We need to join it up with a smooth curve. Okay, try and make sure you're using a single line. Mine's a bit wobbly, that doesn't really matter so much. What you will get marked down on is feathering, so like when you have like multiple lines like that can lose you mark. Or missing the points entirely, so not actually going through the points will cause you to lose marks. Okay, but it should look something like that. Okay, and then finally it says use your graph to find the year when the gannet population is predicted to reach 1,000. Okay, so this scale n is in thousands, isn't it? So 1,000 is going to be here. Okay, so if I can then get my ruler out and read across from 1 or 1,000 until I hit my line. So read across from 1 until you hit the line. When you hit the line, I'm going to change direction and read downwards. Okay. So the answer I'm looking for is there then, isn't it? So it's a little bit more than 11. So what, 11? Should we go for 11.5? I think I'm going to go for 11.5 there. So use the graph to find the year when the gannet population is predicted to reach 1,000. Okay, well I think 11, it's somewhere between 11 and 12, isn't it? But 11 it won't quite have reached 1,000, it'll be a little bit below, so I'm going to go for 12. So that's 12 years after the 1st of January 2010. So 2010 plus 12 is going to be 2022. So I'm going to say 2022 is my answer. Now if you'd have rounded the other way to 2021, I think you would probably get the mark in this case as well. Just wanted to take a few seconds out to talk about my Patreon page, which you can find at patreon.com/Mr. Tompkins EdTech. On here you can gain access to exclusive content, including early access to my past paper walkthroughs. So if you like my content, definitely worth checking that out. Also, if you become a Pythagorean patron, you get a special shout out in every video. So check it out. Back to the maths. Question 22. In a village, the ratio of males to females is 2:1. 40% of the people in the village are right-handed males. 25% of the people in the village are right-handed females. Show that the proportion of females who are right-handed is greater than the proportion of males who are right-handed. Now, students often find these sort of questions tricky because there's not a number given for the number of people in the village. So you're finding, they're thinking 40% of what, or to divide what in the ratio of 2 to 1, and it's difficult for them to come up with an answer. So often I think it's useful just to assume a number of people that you're talking about. Now, often when it's percentages like this, I would assume there are 100 people and then divide it up into 40 and 25, whatever like that. But the difficulty here is I've got a ratio up here of 2 to 1, and it's difficult to divide 100 up into 3 parts. It doesn't divide nicely. So I'm going to assume then that there are, I'd normally go for 100, but it doesn't divide by 3. So I'm going to go for 300. So I'm going to assume 300 people in the village, just so that I can do the calculation without worrying too much about it. Okay, so then so let's say all of these, this bar here is all the people in the village. It's 300 people, isn't it? So if I divide that up into 3, then I've got 100, 100, 100, haven't I? So then that there would be the females. And there's 100 there. And then this would be the males then, wouldn't it? There's 200. There's twice as many males as there are females. Okay? 40% of the people who are in the village are right-handed males. Okay, so if I take that same bar then, which is made out of 300, and I want to find 40% of it, that's going to be 3 lots of 40 then, isn't it? It's going to be 40, 40, 40, which is 120. Okay, so of my 200 males, I'm going to have 40 times 3, 120 of those who are right-handed. And then the lefties are going to be the remainder, isn't it? It's going to be the 80 that are left. Okay? Now, in my female bar, which is of length 100, 25% of the people in the village are right-handed females. So 25% of 300 is 25, 25, 25. That's 75, isn't it? So this bar here, I'm going to divide up into 75 righties and 25 lefties. Okay? So show that the proportion of females who are right-handed is greater than the proportion of males who are right-handed. Okay, so the proportion of males who are right-handed is going to be these guys here, this 120, as a fraction of the males, isn't it? Okay. So the proportion of right-handed males is going to be 120 over 200. And that is equal to, well, it cancels down, doesn't it? That's 60 out of 200. That's, sorry, 60 out of 100, that's 60%. So 60% of the males are right-handed. And then for females, so right-handed females, that's going to be my 75 right-handed females out of a total of 100 females, then, isn't it? So that's going to be 75 over 100, which is 75%. Okay, show that the proportion of females who are right-handed is greater than the proportion of males who are right-handed. Well, 75% is bigger than 60%. So I think that's enough. We've shown, we found the proportion of men who are right-handed and the proportion of women who are right-handed, and we've seen that one is bigger than the other. So I think that's enough.
You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.